Good afternoon, everybody, and welcome back to another glorious day. Today, we are going to be looking at the um, the attributes that you can use to classify quadrilaterals. Um, and so you should get a copy of this notes page. Um, I will let you know where those are stored and where to find them. So you will need, once you complete these notes, you will need to glue them into your math notebook. I highly recommend that you fold it in half horizontally, put glue on one half so that it's glued down to your notebook and you can lift the flap to look at your notes. Okay. If you have questions about how to do that, please don't hesitate to raise your hand and ask. I will be more than happy to help you with it. So let's start with the information that they've given us. They've given us pictures of parallelograms, rectangles, squares, rhombuses, and trapezoids. Now with the parallelogram, the rectangle and the square, and even the rhombus, you're going to see some things that are similar. But it's in the definition of each one that determines how things fit everywhere. Okay, so let's take a look at parallelograms. We know that parallelograms are quadrilaterals. So four sides, so we're going to write quadrilaterals. Okay, and they have four vertices. So 1, 2, 3, 4, and 1, 2, 3, 4. Check and check. Now with parallelograms, we know that the opposite sides are congruent. And if you remember, congruent means equal. We also know that opposite angles are congruent. And that opposite sides are parallel. Okay, so this means that if we labeled A, B, C, and D, for this figure, it says that opposite sides are congruent. So this means that AB and CD are equal, and BC and AD are equal. And we can write this out. We can say that line AB is equal to line CD, and that line BC is equal to line AD. We know that based on the definition. It says opposite angles are congruent. So this means that, I'm going to come down here, angle BAD is going to be equal to angle BCD. And it also means that angle ABC is equal to angle ADC. Okay. We also know based on this definition, and I'm going to put this up here just so we're in the same column, that line AB is parallel to line CD, and line BC is parallel to line AD. Okay. So there's how you can write these based on those geometric symbols and terms. And it's a good way to be able to analyze the shapes that you're given. All right, so let's take a look at rectangles. And as I'm looking at this, I'm noticing, hey, all one, two, three, four, five of these have 4 sides and 4 vertices. So this means that they are all quadrilaterals. Oh, look at that. The title of our chart is Quadrilaterals. I'm going to write this down here to remind myself. Because quadrilaterals have 4 sides and 4 vertices. All right, let's move on to rectangles. Now, we know that on a rectangle, opposite sides are congruent. Okay, I'm going to grab a different color pen this time to help you guys kind of differentiate with the colors that I'm using. Purple and green should be okay. So if I'm choosing to label, let's see here, we'll use this one. E, F, G, and H. Okay, so opposite sides are congruent. This means that this side is congruent to this side, and this side is congruent to this side. Now we know that this shape is a square, so it's automatically going to be that all 4 of them are equal. But with a rectangle, it's just that opposite sides are congruent. So technically, a square can be a rectangle. So this means that line EF is equal to line HG, and line FG is equal to line EH. Okay, opposite sides are congruent. Now, the next piece is it has 4 right angles, which means that they're 90 degrees. Okay. They create that square angle. Now you can go through and measure these, but if anybody remembers the trick that I showed you in another video, is to use a piece of paper. In my instance, I am going to use a sticky note pad because sticky note pads have right angles, and I'm just going to line this up here. Yep, that's a right angle. Yep, that's a right angle. If it lines up perfectly with the corner of a piece of paper, it's a right angle. Yep, HGF, FGH, that's a right angle. What about FEH? FEH, yep. So all you have to do if you're unsure if something's a right angle, use a piece of paper. Use something that you know is 90 degrees. Okay? So they all have 4 right angles. Also, opposite sides are parallel. Okay, so this means that line EF is parallel to line GH, and line FG is parallel to line Yeah, F-G-E-H, E-F-G-H. Okay, yeah. Just want to make sure I had my lines labeled correctly. All right. Now, rectangles can also be called parallelograms. Now, if we remember correctly, and I'm going to slide down here and I'm going to rewrite this definition because parallelograms are very, 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 very important. Okay. And you need to focus on this word can be. Not that they always are, but they can be, because a parallelogram has opposite parallel sides that are all what? I'm going to give you a couple seconds to think. It's not just that opposite sides are parallel, but that they're parallel and they are all what? Let's see if you can remember what I'm thinking. Anybody? Okay. Opposite parallel sides that are also opposite equal sides. Okay. So for instance, a square is a rectangle, but it is also a parallelogram because we have opposite parallel sides and the opposite sides are equal. The same with these two, the same with these two. Okay. All right. But you always need to make sure that when you're looking at a figure that you're thinking about all the definitions of these to really make sure, does it fit here or not? Okay. Now, a square, once again, it's a quadrilateral, 4 sides, 4 vertices, and opposite sides are congruent. All sides are congruent. Four right angles. Opposite sides are parallel. Can also be called a parallelogram. And actually, we're going to come down here for just a second because I messed up. Parallelograms are only have opposite parallel sides. Take out the rest of this. I messed up. My bad. My brain confused the definitions there for a second. Parallelograms, opposite parallel sides. Okay. So a square can also be called a parallelogram. It can also be called a rectangle. And it can also be called a rhombus. All right. Now, I'm not going to go through and label the sides because I think at this point you should be able to understand what I mean based on what we've done with the first two. Okay. Now, a rhombus. This is where a lot of students start getting confused because all squares are rhombuses, but not all rhombuses are squares. And it's mainly because of this right here, the 4 right angles. On a square, there are always 4 right angles, and all 4 sides are congruent. They're all the same length. Now, a rhombus has opposite sides that are congruent. All sides are congruent. So this means that all 4 sides are the same length. All sides are congruent. Opposite sides are parallel. And it can also be called a parallelogram. Okay. So we have opposite sides are congruent, all sides are congruent, opposite sides are parallel. On a rhombus, the only difference between a rhombus and a square is that on a rhombus, the angles do not have to equal 90 degrees. So I'm going to write this. Angles do not have to be 90 degrees. Okay. This is the difference between a rhombus and a square. Rhombuses do not have to be 90 degrees. All squares have congruent sides. All squares have opposite sides that are parallel. That's why all squares are also rhombuses, but not all rhombuses are squares. Because if you look up here, see here, I, J, K, and L. I can look at this and go, okay, well, I know that angle JIL is obtuse, and I can even prove it. I can pull out my sticky note pads. I know this is 90 degrees, line it up, and that angle is larger than 90 degrees. So I know it's obtuse. If I line up the angle ILK, it's acute. It's less than 90 degrees. So is angle J. So these two do not have 90-degree angles, but they do have all congruent sides and parallel opposite sides. That's why rhombuses are parallelograms. That's why all squares are rhombuses, but not all rhombuses are squares. This is where those definitions can either help you or hurt you. Now let's look at a trapezoid. Trapezoids have one pair of parallel lines. Okay, so for this one, it's the top and bottom line are parallel. On this one, top and bottom. On this one, top and bottom. This one, it's side to side. This one, it's top and bottom. One pair of parallel lines, as long as it's a quadrilateral, and one pair of parallel lines, it's a trapezoid. Okay. All right, I know this was a lot, but if you use this to study, if you use this to create your flashcards, it will help you. I can tell you right now, most students do not struggle with the concept of parallelograms, of rectangles or trapezoids. Where they get confused is the connection of rhombus to square and square to rectangle. Okay. So make sure that you understand these little tiny differences. All right. Well, thank you guys so much for watching today. I really appreciate it, and we will see you next time.